This presentation outlines the critical steps involved in a submarine cable restoration project, a vital operation that ensures resilience and continuity global communications infrastructure. Now let's take a closer look at the 4 key components of a cable restoration project. 1. Fault detection. Identifying both the location and cause of the disruption. This is accomplished using advanced network monitoring systems and diagnostic tools that analyze signal loss, latency, and performance anomalies across the network.
Ini kan satuannya kilometer. Nah, ini panjang totalnya. Ini dari titik 0, titik 1, dari ujung sini saya sampai ke titik yang 10 ini terakhir.
The most common causes of submarine cable damage include human activity, such as fishing operations, ship anchors, and dredging. Natural events, including underwater earthquakes, landslides, and tectonic movement. Environmental wear and tear, like corrosion, strong ocean currents, or seabed instability. Accurate detection is essential. It allows for targeting planning, minimizes service interruption, and ensures that the appropriate resources are deployed for repair. 2. Deployment of cable repair ship. Once the fault is confirmed, a specialized cable repair vessel is dispatched to the affected site. These ships are purpose-built and equipped with trenchers, heavy-duty subsea equipment used to disturb and search the seabed to locate buried or displaced cables, grapnels, mechanical tools lowered to physically recover the identified cable from the ocean floor, precision cutting and optical fiber splicing tools, essential for removing damaged segments and reconnecting the cable with high accuracy. Time is critical. Depending on the cable's location, the repair vessel may need to travel hundreds or even thousands of kilometers. Additionally, weather and sea conditions can significantly impact travel and on-site operations. For this reason, efficient coordination, readiness, and real-time decision-making are essential to minimize service disruptions and restore connectivity as quickly as possible. Moving on to cable restoration process. Once on site, the ship's crew follows a standardized restoration workflow, which includes locating and lifting the damaged section of cable to the surface, cutting and removing the faulty segment, splicing a new cable segment using specialized tools to reconnect the optical fibers with precision, carefully lowering the repaired cable back onto the seabed and securing it to prevent future damage. This process requires a combination of technical expertise, precision, and adherence to international standards to ensure long-term operational reliability. Final testing and monitoring. After physical restoration is complete, the cable undergoes a series of post-repair tests to verify signal quality, optical integrity, data transmission stability. Once the cable passes all required tests, it is returned to full operational status.